combining the definition of a logarithm to be an exponent and the properties, we're now going to show mathematically how to solve for that exponent t, not using guess and check, but using the idea of a logarithm. In algebra, we always keep the right hand equal to the left hand. So what I do to one right hand, I must do to the other left hand. So what I'm going to do is I'm going to go logging. So I'm going to put the word log on the left, and that's going to be equal to log 3 raised to the t. Using my properties of logarithms, log of 10 equals t log of 3. We have a power. We can multiply those two exponents. Solving for my variable t through division. Now the log by itself does not mean anything. You must keep log 10 divided by log 3. So to actually find a value for this value on t, what I'm going to do is plug in the log, and notice there's a log right on a calculator, and it's the log of 10, which I know that that's 1. I'm going to write it as log of 10 divided by log of 3. Notice the logs do not cancel out. So once I plug in log of 3, I get this exponent of 2.095, so forth. So if I try this and take 3, raise it to the power of 2.0959032, etc., I should get very close to 10. Looks like I put an extra decimal in there. Should get really close to 10. And if I had not stopped my exponent, I would have gotten the exact value of 10. So once again, I plugged in log of 10 divided by log of 3, and that is the power. And one way to show it on the calculator, because you can tell I made a mistake when retyping something, I can take 3 and raise it to that long exponent by going second answer, and it would take the answer from the line above, and you can see that I get exactly 10. So what it would be an application of using a logarithm to solve for this unknown exponent. It happens a lot when investing. There's a formula, and just to dissect the formula, A is the amount you accrue. We'll just call it the amount. It's the ending amount after your investment. P is the principal, and the principal is what you start with. How much did you put into the bank? R is my rate. We must always put it in decimal form, and T is time. So the situation says that I have $100 and I'm going to invest it at 5%, and I want the end result to be 500. So I want to end up with 500 after I started with 100. You have a 1 in this position, which says keep the $100 and add it to the interest that you're going to be getting, and the interest is at 5%. So notice I converted it to a decimal, and I'm going to raise that to some unknown time period. That's what I'm looking for. So in order to solve this, I want to get this variable t by itself. So there's a few things I can do and need to do before I go logging. The first is I'm going to divide by 100. It's multiplied on that whole quantity, so I can divide, and I end up with 5. The next thing I'm going to do is simplify what's in the parentheses. That's 1 and 5/100ths. Take it to the power of t. And now it looks similar to the problem we did earlier. Again, I can guess and check on a calculator, but it's very time consuming. So I'm going to take the log, keeping my left hand side equal to my right hand side. Using property 3, the power property says that when I have two exponents being multiplied, I'm going to rewrite it as t log of 1 500ths. Now, again, I'm trying to isolate this variable t. So in order to do that, I must get rid of this log by division, because it's multiplied by the variable t, time, in which I'm looking for. On my calculator, I take log of 5 and divide it by that other log. So I'm going to go log of 5 divided by the log of 1 5/100. When I push enter, it tells me it's going to take me 32, almost 33 years for me to take $100 and make it worth 500. So your money does grow exponentially. Does take a while, but if you think about $100, I quadrupled it 5 times itself, and it happened in approximately 33 years.